two people in the lab, a postdoc named Kai Pappenfort and a graduate student named Justin Silpe, were working on Vibrio cholera because we study quorum sensing in Vibrio cholera. And they happened onto a gene, a new gene, which when they were measuring when was Vibrio cholera expressing that gene, it didn't express it at low cell density, but when cholera grew to high cell density, this gene turned on. And in my lab, when something doesn't happen at low cell density and it turns on at high cell density, we're like, ding, 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 that's quorum sensing, right? The bacteria only turn it on when they're in a group. And so we're like, oh, great, we have this new quorum sensing gene. So that was fine. So then Justin and Kai wanted to understand which of the cholera autoinducers, which we had discovered long ago, which of them is most responsible, or both, for turning on that new gene. So then they made a mutant that was incapable of making either of the known quorum sensing autoinducers. And in that mutant, they followed that gene, and it turned on at high cell density just fine. And so that was a eureka moment, because they were like, it's not the autoinducers we know about. So there had to be something else that cholera was making in the absence of the two known autoinducers that was turning on this new gene at high cell density. So a new autoinducer. And so they reasoned that, and so then what they did was they grew up huge amounts of cholera, spun the cells out of the tube, right, and the autoinducer is on the outside. They collected up all that growth medium that cholera had grown in, that this fantasy, mystery autoinducer was in, and they did very standard biochemistry. They just fractionated, we call it. They just made cuts of these growth medium and pared it down until finally they had one molecule in their tube. They figured out the structure of it, and it's this new molecule that we call DPO. And so that is our newest autoinducer. And so after all of these years, there's still many more of these chemical words to find, even in these well-studied bacteria. And so we're excited to be onto a brand new quorum sensing system in this bacterium that we have studied for 20 years and thought we knew a lot about. What's really interesting, an interesting twist on quorum sensing in cholera, is that at high cell density, when quorum sensing autoinducers accumulate, cholera shuts off virulence and it tries to get out of the host. So if you provide autoinducers, cholera shuts down pathogenicity. So now Kai and Justin have a new autoinducer, DPO. And the dream is that you could just provide that. Like I could make a tablet, for example, of DPO and give it to you, and maybe you could take it, and that would suppress cholera virulence, right? The other thing that's really interesting that Kai and Justin showed is that DPO is not only made, this autoinducer DPO is not only made by cholera. In fact, it's made by many of these microbiome bacteria that live naturally in the gut. So what we think is that the microbiome bacteria are making DPO, and that is being used in the gut to fend off, this invader, cholera. And so maybe another strategy could be to actually get these microbiome bacteria that live in us naturally to make more DPO or make it on demand, and that they could do the fighting against cholera, and it would be a more natural kind of medicine. It would be your own commensal or mutualistic bacteria fighting off this invader that's not supposed to be there. And so those are sort of our two ideas right now for using DPO as a medicine. So it could be DPO or a derivative of DPO, a DPO-like molecule, and either we're going to make it, hopefully, or we're going to get your bacteria, your normal bacteria, to make it in the hopes of making people healthier.